Video is on section 2.1, so we're starting chapter 2. Starting chapter 2, we're going to get into a little bit more of the Algebra 2 material that you may or may not have remember or did back in Algebra 2 last year with COVID stuff. So the first thing we're going to talk about is continuity. Continuity of a graph basically means if you can put your pencil down and continue the graph all the way through, it's continuous, okay? So if we can draw it without lifting our pencil, that's not official, but yeah, if we can continue it through without. If it's not continuous, we call it discontinuous, okay? So if we put our pencil down here and we draw it, okay, I come to this point, oh, I got to lift my pencil to get to that point. So this is discontinuous, and it's discontinuous at x equals 2. Okay, this one here, put my pencil down, it'll keep going, up. I have to lift my pencil up to get to this point and go over here. So this is also discontinuous at x, we'll say x equals 2. And if you remember this vertical line here is called an asymptote. Okay. That vertical line, imaginary line there where it gets closer and closer and closer and never crosses, gets closer and closer and never crosses, is called an asymptote. Okay, this one I put my pencil down and it keeps going the whole way. That is a continuous function. This one here, draw it. Okay, now I have an open circle, which means it's not equal to there, so I have to pick my pencil and go up over 1 and then come back over, right? So that's discontinuous. Okay, at x equals whatever that is, 1. Okay, this one here. This one has another asymptote right here, where this is going to get closer and closer and closer and closer and closer to that line, but it'll never cross over. And same thing here, and never cross over, and they'll never touch each other either. So I come here, and then I have to pick it up to come over to that side and come down. So that's also discontinuous at x equals, let's say it's at 2 or whatever there. Okay, so that's the idea of continuity. Back also in Algebra 2, we talked about where it is increasing or decreasing. So this graph looks like this. Okay, it's going to keep going in all directions. So if I'm going to start on the left side and go to the right, and are my y's, are my outputs getting larger or are they getting smaller? Okay, so my outputs keep getting larger and larger and larger. So we're going to say this is increasing. And we have to tell the interval where it's increasing. So from when it starts here at negative infinity, it starts increasing, 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 and it keeps increasing all the way through to infinity. So from negative infinity to positive infinity, it's increasing that whole time. Okay, whereas this one here, okay, if we go from left to right, it is decreasing the whole time. Okay, so it's decreasing the whole time there. And it's decreasing the whole time from negative infinity all the way up through positive infinity. Okay, now if you look at this one here, my y, let's just say that's y of 2 there. My y stays at 2 the whole time. Okay, so it's a constant. And it's constant the whole time from negative infinity all the way through positive infinity. The whole time is constant. Okay, this one's doing a couple of different things. Okay, so if we start on the left side, okay, start at negative infinity, right? So we're going to keep going, and we are going down. We're decreasing. And we're decreasing in the interval from negative infinity all the way up through 1. Okay, now notice that's an open circle at 1. So using our interval notation, it's parentheses. Okay. And then at 1 here, it is doing this, so it's increasing. Our y's are getting larger. So it's increasing from 1 to 3. So from 1 to 3, it's increasing. Now, I made a little mistake there. Notice that we're equal to at 1. I need to have that bracket. And at 3, it's also we're equal to there, so that bracket. Okay? And then from 3 here up through infinity, it is constant. from 3 to infinity. Okay? And for E, okay, so start on the left side. It's coming down, so it's decreasing from negative infinity up until negative 2. And then at negative 2, it stops going down and it starts going up. So it's going to be increasing from negative 2 to infinity. Okay? So that's the idea of increasing and decreasing functions. I think you got to that last year in Algebra 2 before COVID hit, so hopefully that's a review thing for you. If not, tell me in class and we'll review it a lot more. Okay, next we're going to look at 3 different functions. We're going to look at y equals x squared, and y equals x to the third. Okay, so these functions, y equals x, this graph looks like this. So for every x, right, if I plug that in, I get an output that's the same thing. So 1, 1, 2, 2, 3, 3, 4, 4, there's that function. Okay, the domain are our x values. Domain keeps going this direction and it keeps going this direction. So our domain is all real numbers. Range, okay, think about the y values. And it keeps going down, 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 and it keeps going up, up, up. So that's also all real numbers. And continuous, we talked about that earlier. If I can put a pencil down, draw it the whole way, it is continuous. So we'll say, yes, it is continuous. And is it increasing or decreasing? Okay, so if I put my pencil on the left side and draw it, it is increasing. And it's increasing the whole time, all the way from negative infinity up through positive infinity. The whole time it is increasing, never decreasing or stopping. Okay. The squared function, y equals x squared, looks like this. If I use negative numbers, squared makes it positive, right? So if I go negative 416 is the same y as if it's a positive 4, right? 4 squared and negative 4 squared both give you the same thing, so it's symmetric there. Our domain, okay, think about this will keep going down, down, down for all these x's. This keep going up, up, up for all these x's. So once again, that's all real numbers. Our range are our y values, so our outputs. Think about these y's here. 0, 0, if I square 0 in here, 0 squared is 0, so I have this point 0, 0. Can I ever square it, a number, and have it be negative output? Nope. It's always positive, right? So our range can be 0 up through our positive numbers. So from 0, including 0, to infinity. Is it continuous? Can I put my pencil down and draw it all the way through? Yes, it is. Okay. The increasing part and decreasing, okay, if I start on the left side, this is decreasing. Okay, so it's decreasing first. And that's from negative infinity up until 0. It's decreasing that whole time. And then it starts to increase from 0 through positive infinity. It'll be increasing for all those x's there. Okay. I'll talk about this here a little bit too. We'll get more to this a little bit later. But if you look at this, is it symmetric with respect to the y-axis? So my y-axis right here, is it symmetric on both sides? Okay, can I reflect it across and it be exactly the same? Yes, it is. Okay. So if it's reflected across the y-axis, that is called an even function. We're going to talk about odd and even functions. It's an even function. And I'll just put this equation here for right now, and we'll talk about it a little bit later. That means that f of negative x is equal to f of x. Okay? We'll talk more about that a little later. Okay, a cubic function. If I take a number and cube it, okay, 2 cubed is 8, 3 cubed is 27, okay, etc. The cubic function looks like this. Farther away it gets from 0, the more cubing makes it higher. Okay. So the cubic function, our domain, okay, it'll keep going down, 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 down for all the way through negative infinity. It'll keep going up, 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 up through positive infinity. So our domain goes from negative infinity to positive infinity. Okay, our range, think about the y values here that are possible. When I cube a negative number, I still get a negative number. So I can get negative numbers here. So it goes down to negative infinity, and it'll keep going up to positive infinity. Okay, and it's continuous. Can I put my pencil down and draw it the whole way through? Yes, it is. Okay, and from left to right, I put my pencil down, and it's going up, 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 and it goes up not as fast, but it's still going up, and it keeps going up. So it's increasing the whole time from negative infinity to positive infinity. Okay. Now, this idea with symmetric, okay, so it's not symmetric across your x-axis, your y-axis. It's not symmetric across your x-axis. We call this symmetric across the origin, okay? Basically, it's a 180-degree rotation, if you remember back in geometry. If I take this and I rotate it 180 degrees around, it's reflected across, we call that across the origin, okay? So yes, it's reflected across the origin, and we're going to call that an odd function. So an even function is when it's reflected across the y. An odd function is when it's reflected across the origin. And we have this equation called f of negative x will equal negative f of x. Okay, so we're going to use those two equations a little bit later to figure out if a function is odd or even. Okay, so getting the idea there. So, first one here, we want to show that it's symmetric across the y-axis. So y-axis, we're using this equation right here. So f of negative x is equal to f of x. Okay, so we know f of x is this, right? So that's this function right here. Now, to find f of negative x, just like if I wanted you to find f of 2, you would take that 2 and you'd plug it in here for these x's and work it out, right? Same idea here. We're going to take negative x and plug it in here. So we have negative x to the 4th minus 3 times negative x squared and minus 8. Okay, so I work this out. This is like a negative 1 to the 4th power. It makes it a positive 1. So this would be x to the 4th. Negative x squared is just same thing as x squared because negative 1 squared is still 1. So it gives me negative 3x squared and then minus 8. Notice that when I worked that out, gave me the same thing as this over here. Okay, so yes, this would be symmetric across the y-axis. Okay, now the next one there, we want to show if it's symmetric to the origin, so we're going to use this equation here. We want to show that f of negative x, so both of them we're finding f of negative x, is equal to negative f of x. Okay, so once again, we're taking this negative x and plugging it in for both of the x's here. So we have negative x to the 3rd minus 4 times negative x. And on the other side, I want negative of the whole function. So negative of this whole function. Okay, so now I have to work those out. So a negative 1 to the 3rd power, negative 1 times negative 1 times negative 1, gives you negative 1, so it would still be negative x to the 3rd. And negative 4 times negative x makes that a positive 4x. Okay? And over here, if I distribute that negative through, I have negative x to the 3rd plus 4x. So you notice this side does equal this side. So yes, it is an odd function. It is reflected across the origin. Okay, so that's how we tell those. Okay, a couple other functions we should know about. The square root function. Can I take the square root of a negative number? If I take the square root of negative 2, does that work? If you remember, it gives you an I function, right? Imaginary, so that's not real on our number line here. But I can at 0. Square root of 0 is 0. Square root of 1 is 1. Square root of 2 is a 1.4. Square root of 4 is 2. Okay, so the function goes up and looks like this, starts to level out. That's what the square root function looks like. Okay, our domain. Okay, we don't have any x values down here, but they start at 0. And I can find the square root of 0, so 0. And it'll keep going out here through infinity. Okay, range. I don't have any negative numbers here, but it starts at 0, and it will keep going up, 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 these values right here. Okay, so my range goes from 0 to infinity as well. And if I start here and I keep going, it is continuous over from 0 to infinity. So if I can create an interval that it is continuous over. Okay, it is never decreasing at any time. It is increasing the whole time. So it's increasing from 0 through infinity. The whole time here it's increasing. And is there any symmetry? Across the x-axis, y-axis, nope. Across the origin, nope. So no symmetry to this one. Okay, cubed root of x. Okay, if I find the cubed root of that number, of any number, it gives you something like this. Very similar to the x to the third, but instead of x to the third increasing a lot, cubed root doesn't increase as much there. Okay, the domain. Okay, we keep going this way for our x's. We keep going this way for our y's. So that's going to be all real numbers. Okay, our range. This doesn't increase it increases a lot here and doesn't increase as much here, but it is going to keep going up, up, up. So this is increasing there and decreasing, going down over there. So my range is also all real numbers. It is continuous because I can keep drawing it the whole time. I don't have to lift my pencil. So yes. And from left to right, it is going up, 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 up the whole time. So it is increasing from negative infinity to infinity. Okay. And symmetric, it's not across the y, not across the x, but it is, if you rotate that around 180 degrees, it is reflected across the origin. Okay, which is the equation, right? If we plug the negative x in there to this equation, plug that in, that is equal to the negative of that function. Okay, those two things are equal, so it is across the origin. Okay, absolute value function. If I take the absolute value of a number, it makes it positive. So absolute value of negative 2 is 2. Same as 2 is also 2. You can see you have this V shape is the absolute value function. The domain, okay, x's keep going this way, x's keep going this way, so all real numbers. The range, I can't take the absolute value and have it be negative, so there's no negative numbers here, but 0, absolute value of 0 is 0. It'll be positive numbers too. So my range is going to be from 0 through infinity. Okay. Continuous, I can start here and I can draw the whole way through. So yes, it is continuous. Okay, here from left to right, it is decreasing. So it's decreasing from negative infinity up through 0. Okay, and then at 0, it changes and it starts to increase then. So from 0 through infinity, it starts to increase. Okay, and this is, you can see here, symmetric across your y-axis. Okay, so can a function be symmetric to the x-axis? Okay, so if we choose to do this function instead, x equals y squared. So if I pick any x's and I square these, okay, anyway, if I put this in here for this x, the opposite of squaring this is taking the square root, right? But anyway, what this graph would, this is all for y. So if I take the square root of both sides, I have y is equal to plus or minus the square root of x. So this gives me actually two different equations. So we have the square root of x and we have the negative square root of x. So the square root of x looks like this. The negative square root of x looks like this. Okay? So this right here, if I take this function as it is, the whole thing, is it really a function? Remember, it doesn't pass the vertical line test, right? So it's not really a function. So it can't be a function and be reflected across your x-axis, but it could be a relation. Like we could have this, and it could be reflected across as two different functions. We could have this function and this function, which then make it reflected across the x. But okay. So we call that, when we have to use two different equations to it, we call it piecewise. Like up here in this one, you could think this is y equals negative x, this is y equals x. You could think of that as two separate equations. Here you have square root of x and negative square root of x with two different equations there. Okay, but let's just take this as it is. Our domain, okay, we don't have any negative numbers, but we do start at 0 and go to our positive numbers. So from 0 to infinity. Our range, okay, we do have these numbers going up, 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 up. And we have these numbers going down, 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 down. So from negative infinity to positive infinity. Okay. Okay, so a little synopsis here. If something is reflected across the y-axis, this is an example, right? Reflected across your y-axis. If you think about just the certain points, if I have the point AB, if that is a point on the graph, if it's reflected across your y-axis, then negative AB would also be in there. So for example, let's take this. If I have the point 1, 2, 4, okay, so let's say this is the point 2, 4, then that would also say that negative 2, 4 should also be on there. So negative 2, 4 would also be on that if it's reflected across your y-axis. Okay? If it's reflected across your origin. Okay, so we had an example that looks something like this, was reflected across the origin. Okay, that idea of the rotation around. So if AB is on that graph, so let's say I take the point, this point right here, let's just say it's the point 1, 2. I'm just kind of making that up. Okay, then negative A, negative B will also be on it. So negative 1 and negative 2 would also have to be on that if it's rotated around and reflected across the origin. If something is reflected across your x-axis, it's not a function, but if it is, if AB is on there, so I'll just make something up like the point 1, 2 again, then a negative B would have to be on there. So 1, negative 2 would have to be on there. Okay, so that you can think about those points there. Okay, last section here. We want to decide if these are odd or even. Okay, we had said earlier, if it's even, it's going to, if I plug x into the function, it should equal the same function back. Okay, that's a y-axis symmetry. And it's odd if I plug the negative x in, and it equals the negative of the original function. Okay, and that was the reflected across the origin. Okay, so if I do this one here, we just kind of have to guess which one it might be. So I'm going to guess this one first. Okay, so if I plug the, I'm going to test for if something's even first, and if not, then I would have to test for the odd. Okay, so if I plug f of negative x, it has to equal f of x if it is. So if I plug a negative in here, so plug the negative in for that, I would have negative x squared. Okay, and if I square a negative number, it turns out to be a positive number. And does that give me the same thing as my original function? Yep. So we know that it is even. Okay, x to the third. Okay, let me test the even first. So f of negative x equal f of x. Let's give it a try and see. So if I plug the negative in there, I have negative x to the third power. Okay, a negative to the third power is still negative. Negative times a negative times a negative is still negative. So I have negative x to the third. Is that equal to my original function of x to the third? No, it is not. So it's not even. Let's check for odd. F of negative x equal negative f of x. Let's see if that works. So plug that negative in here. So I have negative x to the third. We talked about that over here being negative x to the third. And then here, the negative of this function is negative x to the third. So yes, it is an odd function. Okay. Part C. Let's do the test for even first. So if I plug it in, f of negative x, f equal f of x, we'll see. So I plug this negative in here. So I have negative square root of negative x. Okay, and I also have the square root of x. Does the square root of negative x equal the square root of x? Well, if x is positive, then I can't take the square root of a negative of it, right? And if it's negative, I can't take the square root of a positive. So it doesn't work. So it doesn't work there. Okay, and then let's check it with this one. So negative f of x, so negative square root of x. Will this equal this? No. So this function is not odd nor even. Okay, so it's neither of them there. Okay, we'll check this one here. Let's find f of negative x. Okay, so I plug it in there. 8 times negative x to the fourth minus 3 times negative x squared. Okay, negative times a negative times a negative times a negative is a positive. So it makes 8x to the fourth. And negative times a negative is a positive. So that makes that negative 3x squared. Notice that is equal to my original function of f of x. So therefore it is even. Okay. Ideally, pause this and do these yourself and give them a try, and then come back and watch. Okay. So we're going to find f of negative x, which would be 6 negative x to the third minus 9 times negative x. Negative times a negative times a negative is a negative. So this would be negative 6x to the third. And negative times a negative is a positive 9x. Okay, so I know it's not equal to f of x here. So let's see if it's equal to negative f of x. So negative f of x would be negative of the 6x to the third minus 9x, which equals negative 6x to the third plus 9x. Same thing. Therefore, it is odd. Okay, so find negative f of x first, plug it in. 3 negative x squared plus 5 times negative x. Negative squared makes it positive, so this would be 3x squared. And a positive times a negative is negative 5x. Okay, so it's not equal to my original. Okay, it's not equal to f of x, so it's not even. Let's check this one. If I put a negative in front, so negative of the 3x squared plus 5x makes that negative 3x squared negative 5x. Not the same there either. So it is neither not odd nor or even. So it's neither of them there. Okay, next one here. If I find f of negative x, okay, so it's 1 over 2 times negative x, which makes it negative 1/2 x, 1 over 2x. Okay, now that's not equal to the original, so let's see the negative of it. So negative of this whole thing, okay, would be negative 1 over 2x. So yes, this one is an odd function. Last one. Okay, f of negative x, plug it in there. So I have 5 times negative x, an absolute value. So this would be negative 5x, but absolute value makes it positive, right? So that really is the same thing as this, which is equal to our f of x, which makes it an even function. Okay. All right, so those are the notes for section 2.1.